Okay, guys, so this, just since we didn't have time in class to go over the answers to this, and since you do have an assessment tomorrow, I just wanted to make sure that you understood your answers. So the directions said tell whether the equation graph table shows linear or nonlinear. If it's linear, increase or decrease. And then I also asked you to tell me what the slope was. So this one, we talked about the last day that you were in class, not remote. We said that if there's an exponent, then it is nonlinear. This one, linear, there's no exponent, there's no variable in the denominator, square root, and there's not more than two variables. So this is linear. And the slope, as we represent with m right here, is 4. It's a positive 4. Since it's a positive number, that means it is increasing. And then this x is a exponent in this case, so that does cause a curve, nonlinear. This one, this is a straight line, so it means it is linear. I'll go over finding the slope to this in just a second. These two are both nonlinear because they are not straight lines, they're curved. I'm just going to put NL. Okay, so slope for a line, for a straight line, you pick 2 points and you look at rise over run. So I'm going to do, I would say any of those would be easily read points. And you are looking for rise over run. So rise over run. You guys did this last year 100 times, I'm sure, but rise, run, rise, run. Your rise is your vertical. That's your change in y. Isn't it your y, your vertical? That's your axis. Your vertical axis is your y. So your change in y is your rise, and I went up 3 in this case, over 2. Rise 3 over 2. Rise 3 over 2. So my slope is a 3 over 2, and it is increasing, obviously, because that's a positive line. Okay, down here, there was one of them that was linear, and I believe I said in class that you ended up with 3 linears. So we have a linear in the equations, we have a linear in the graph, and now we have a linear in the tables. So remember slope, I'm going to jot it down here. Slope is change in y over change in x. And we saw that in the graphs by looking at rise over run, vertical over horizontal. So I'm actually going to, we got to do all of it, don't we? So I'm going to look at this side first. Usually I would tell you to look at your change in y first, but just looking at those decimals, I'm gonna pause on that for a second, just because -2, -1, 0, 1, 2, I can see that that's going up 1 every single time. So I'm just, instead of writing +1, +1, +1, +1, I'm just going to write +1 with an arrow, telling me that it is constant change in x every single time. And then this is 0.2, or 0.2 repeating. So for it to be linear, this has to be going up 0.2 repeating, and it's not. So at that point, you can stop. And you can even see here, from 1 to 3, I'm going up 2. So my slope right there is 2 over 1. And then my slope between these points, 3 to 9, is 6. And this point has a slope of 6 over 1. So you could totally ignore the decimals there if that's confusing to you. But for linear, nonlinear, you have to make sure that your slope is consistent throughout. And since this is not, then it is nonlinear. Okay, and we can just say not constant ROC, rate of change, slope. This one might change in y. Okay, so 7 to 2, I'm subtracting 5. 2 to negative 1, I'm subtracting 3. Negative 1 to negative 2, I'm subtracting 1. And then from 2 to 1, I am adding 1. Okay, weird, but that's fine. Here, 2 to negative 1, I'm adding 1. Okay, so I'm going to stop here. I'm going to look just between these 2 points. From negative 5 to 1, my slope right now is a negative 5. Because it's y over x, negative 5 over 1. So for this to be linear, the slopes have to consistently be negative 5 between every single point. So negative 3 over from negative 1 to 0. Actually, all these are plus 1 again. These are all different, so this is nonlinear as well because it does not have a constant rate of change. And then this one, you can assume, since I told you guys already, that there are 3 linear ones, but you do have to realize why, and you can tell me what the slope is. Let's find my change in y. Negative 2 to 1, I am adding 3. 1 to 4, I'm adding 3. 4 to 7, I'm adding 3. Adding 3. Okay. And then from negative 2 to 1, I am adding 1. Adding 1, and I'm adding 1 and adding 1. Okay. So my slope is 3 over 1. 3 over 1. 3 over 1. 3 over 1. That was nice and easy. So that is linear because I have a constant rate of change, aka slope. I have a constant slope of 3 increasing up. Okay, give an example of a graph table equation of a nonlinear function. So graph, I don't know why I decided to put it in a box. I'm losing my mind today. I'm going to do some different color. Nonlinear, make it curved. You do need to make sure that it is a function though. Okay, so you couldn't have given me something like this. Okay, something that's not a function. This is a function and it's nonlinear. Table. Let's just make it easy. 1, 2, 3, 4, 5. I'm going to have my x's go up constantly. And 3 going up by 2. Okay. So here I'm going up plus 2, plus 3, plus 4, plus 5, which is okay. This would just have to be proportional to it, and it's not. This is going up 1 every single time. Okay, so my slope for between these points is 2 over 1, y over x. This is 3 over 1, this is 4 over 1, this is 5 over 1. So what this looks like, this line is just getting steeper and steeper and steeper. It's going to look something like that. Okay. So that's going to be nonlinear as well. And then an equation, just anything with an exponent, I'm going to do y equals 5 over x. Okay, because that x is in the denominator. Okay, and that is your homework. If you guys have questions, just email me and let me know.